If you're trying to keep up with the speed of global digital transformation, you probably feel like you're chasing a problem that just keeps getting bigger.
It's exponential, yeah.
Every industry, every government is in this frantic race to upskill its workforce, to modernize, to secure its own tech future.
Mm.
But the complexity, I mean, the sheer cost of building out that kind of infrastructure can feel impossible.
Completely insurmountable.
So today, we're doing a deep dive into a blueprint designed to tackle that exact problem. And this isn't just about some new software. It's about deploying a massive integrated framework, physical and digital, to solve the workforce challenge on a national scale.
That's right. Our sources today are focused on the National Spatial AI Infrastructure, which was pioneered by Eon Reality and Eon AI Ventures. And the mission is pretty clear.
Which is?
To rapidly accelerate national workforce development and really drive that digital transformation. We're looking at a unified system, an integrated national framework that promises a sovereign, end-to-end digital workforce pipeline.
Okay, the claim that really caught my eye, the one that sort of defines this whole approach, is the speed. They claim this entire comprehensive system can be deployed and, fully activated in just 30 to 60 days.
Right.
That sounds almost impossible for a project this big.
It does, because traditionally, these things fail because they take too long. That speed is the critical piece. I mean, if a nation has to wait 2 years for new buildings, the tech is already obsolete. The political will is gone.
Of course.
By deploying in 60 days, the goal is to modernize learning now, elevate skills immediately, and, this is critical, secure the nation's AI future by making sure all that educational data stays sovereign. It stays within its physical borders.
Okay, let's unpack this then, because that speed only matters if people actually use the technology, right? We've seen so many software initiatives fail because they didn't account for, well, human inertia.
Exactly. You can build the greatest platform in the world, but if nobody uses it, it's a waste.
Which brings us to what they call the dual engine strategy.
Precisely. The core idea is that software alone is not enough to drive real systemic change. It's the missing link. You need a physical anchor to drive visibility and, high-impact adoption. So this infrastructure is built on two engines that reinforce each other.
So let's walk through those. Engine A first.
Engine A is the intelligent virtual campus. This is the digital side. It provides the infinite scale you need to train millions of people.
So 247 access, XR simulations, AI-generated courses, all that.
All of it. Verified assessments, dual diplomas, even job pathway systems. It's the whole content creation, distribution, and assessment machine.
So Engine A is the unlimited capacity for training, the digital library, the endless practice field, accessible anywhere.
Exactly.
Yeah.
But that content needs a visible, high-impact home. And that's Engine B, the Spatial AI Centers.
Physical hub.
A whole national network of them. They act as the home for the software. They're designed to accelerate adoption with things like holographic visualization, shared immersive training, and they house the sovereign AI labs. They're the proof that this isn't just another software license.
So if Engine A is the university catalog, Engine B is the state-of-the-art workshop and recruitment center. They need each other.
That's the core benefit. The source material really emphasizes this synergy. It says, by uniting the scale of the intelligent virtual campus with the hands-on adoption power of spatial AI centers, EON provides countries with a rapid pathway to modernize learning.
And the overall aim is pretty ambitious.
Incredibly, to empower 1 billion learners by finally connecting knowledge directly to verifiable skills and ultimately to a higher income.
Okay, that kind of ambition is only possible if you have a structured rollout. Let's get into the deployment, which is broken down into 4 tiers. Tier 1 seems to be the immediate solution, the starter kit.
Yes, Tier 1 is the Spatial AI Lab, and it's designed specifically to solve what they call the cold start problem.
The cold start problem.
Yeah, you can't afford to wait 6 months for architects and construction permits. Tier 1 eliminates that delay. We're talking about a classroom in a box, a mobile kit that activates any standard classroom instantly.
So students can start learning on day 1, even while the bigger stuff is being planned.
That's the idea.
How instant are we talking, though? How fast can a class actually start learning?
Very quickly. There's a great operational example. The pop-up simulation. An instructor just rolls the case in, pulls out some Meta Quest 3S headsets, and within minutes, 10 students are, well, they're not just looking at a diagram of a human heart.
They're standing inside it.
They're standing inside a giant, pulsating 3D model of a human heart, watching the blood flow. Just transforms how you learn these things.
But wait, if you only have 10 headsets, what about the other 30 kids in the class? You're creating an unequal environment right there.
Ah, but they planned for that. That's the shared view experience. The instructor wears a specialized mixed reality commander headset, a MetaQuest 3, and they cast their view to a 4K projector.
So everyone else watches on the big screen.
Right. The other 30 students are watching the immersive simulation live on the wall. They're learning by observation, guided by the instructor. Everyone is engaged at the same time.
That's a clever solution to the classroom management problem. And what about content? Do they have to create it all themselves?
No, but the kit is designed to empower local creation. It comes with tools, like an iPad Pro with a LiDAR scanner. This enables what they call a scan mission.
The scan
So
mission.
a teacher can walk into a local workshop, scan a real engine block, and that LiDAR captures millimeter-accurate 3D data. It instantly creates a digital twin that gets uploaded to the virtual campus for everyone to study.
So they can build their own library of relevant local content fast.
Precisely. It's all about utility over luxury at this stage.
Okay, so that's tier one. It's functional, it's about mobilizing training, but now it gets more ambitious. It moves to what the sources call visible magic.
Right.
Tier two, the Regional Spatial AI Hub. This is designed to be a local center of excellence. What's the jump from utility to magic?
Well, it's about creating buy-in. Tier 1 gets the job done. Tier 2 is about signaling a massive government commitment. You need a facility that looks undeniably futuristic to impress parents, industry partners, everyone.
And how do they do that?
With wow, welcome. Visitors are greeted by a holographic podium that displays a life-sized hologram of the dean, or maybe a rotating 3D artifact, like a jet engine part. It immediately sets a high-tech tone.
It's a recruitment tool. It attracts the best students, the best faculty. But what about the actual industrial training?
That's in spaces like the Deep Dive Design Lab. Here, an engineer can inspect a complex turbine engine using a Sony spatial reality display. The key benefit is it's glasses-free 3D.
No headset.
No headset. They can just move their head to look around virtual parts as if the object was sitting right there in front of them. It's a huge advantage for technical inspection.
Okay, but team training is different. If you have a crew learning safety procedures, isolating them in VR headsets could actually be a problem.
And that's solved by the three-wall immersion CVE. Imagine a room where the simulation is projected on the walls around you. A team of safety officers can practice hazard identification together inside a one-to-one scale underground mine.
Like a holodeck.
Basically, yeah, they can communicate, point, interact naturally.
Right.
That social learning is massive for high-stakes training.
And when they get out into the field,
They use the tool of the trade, lightweight smart glasses, like the XRL Air 2 Ultra. A mechanic can overlay schematics or instructions directly onto the real engine they're working on. Hands are totally free. It's safer. It's more efficient.
okay, now let's scale this up to the national level.
Mm-hmm.
Tier 3, the National Spatial AI Center, the Flagship. This is where it becomes about maximum power projection.
Exactly. The strategy here shifts from adoption to sovereignty and national control. This is about establishing what they call sovereign magic. This Tier 3 facility is a huge 5-zone ecosystem designed to secure national data and project technological power.
Let's talk about that power projection. Zone 1 has life-size teleportation. What does that achieve?
So Zone 1 is the executive showroom. It features an 86-inch holobox teleportation booth. A leader, maybe the Minister of Education, could be hundreds of miles away, but appear as a life-size 4K hologram inside that booth.
In real time.
In real time. They can give a speech, take questions. It projects serious technological capability to the world.
And for mass learning, what happens in the XR auditorium?
That's Zone 2, and it's all about efficiency at scale. A single lecturer on stage can sync 30 student headsets to focus on one tiny detail of a virtual jet engine. Meanwhile, 200 other students were watching on a massive 13,000 lumen screen.
Very efficient. But the core of the strategic investment must be the data control. Zone 3, the brain of the operation.
It is. Zone 3 is the Sovereign AI Lab. This is the security guarantee. It houses a massive locally hosted AI server cluster. All of the nation's sensitive educational data, assessment results, custom AI models, it's all processed locally. It never touches a foreign cloud.
A physical guarantee of data security.
A tangible geographical guarantee. And of course, the content creation gets a major upgrade. I'm guessing they're not just using an iPad Pro here.
Not at all. Zone 4 is the creation studio. This is high-end production. You have render beasts, liquid-cooled workstations with dual RTX 4090s, and more interestingly, a volumetric capture rig.
Oh, what? It's a circular array of cameras used to record holographic lecturers. Once captured, these expert instructors can be deployed as full-sized, speaking 3D holograms to teach anywhere in the country.
Okay, that's maximum power and centralization. So what does this all mean? That kind of centralization risks creating a new digital divide, right? The capital gets all the cool toys and rural areas get left behind.
It would, which is why Tier 4, the National Hub and Spoke Network, is designed specifically to prevent that.
So this is about equity.
Absolutely. The whole point of Tier 4 is bridging that digital divide. The model is central intelligence, local delivery. The central hub, the mothership, has the heavy iron, like the AI server. But then 8 provincial spokes, or satellites, are deployed across the country to guarantee local access.
How do they make sure a student in a remote province doesn't feel like you're getting a downgraded version?
By outfitting everything's spoke with the magic from Tier 2. They all get the Sony spatial displays, the HYP or VSN hologram fans. This ensures a consistent, high-impact experience nationwide. It's about maintaining a standard of excellence.
But connectivity is always the problem in rural areas. Unreliable fiber can kill a whole thing. How do they solve that?
They integrate Starlink high-performance satellite internet at every spoke. It acts as the primary link or as a guaranteed failover. You get a reliable 100 to 350 Mbps connection.
So the spoke is always connected to the mothership.
Always synchronized, regardless of local infrastructure.
That model is really the ultimate benefit. It's a blueprint to, and I'm quoting here, upgrade their workforce, expand economic opportunity, and bridge regional inequalities faster than ever before. It's a full economic uplift package.
It is. The whole system shows that success requires scale, speed, and security. You have rapid deployment, scalable virtual education, high-impact physical training, and guaranteed national control over your AI data. It's a complete roadmap.
It's pretty incredible. The technology creates opportunities for speed and scale that, just weren't possible even a decade ago. It forces you to rethink what's possible in education.
It does. But, and this is a fascinating point, the infrastructure itself shows that transforming human capital, it takes more than just good software. It requires a massive physical transformation, too.
How so?
Well, think about that sovereign AI lab. To keep that massive server cluster running 24/7, the facility has to install high amperage, 3-phase power circuits, a mandatory 10 kVA, uninterruptible power supply for backup, all protected by biometric access controls.
So it's not a simple plug-and-play setup.
Not at all.
Yeah.
And it raises a really important question for any nation looking to do this. When you talk about building the digital future, how prepared is your physical infrastructure, your electricity grids, your cooling capacity, your physical security, for the truly massive power demands that future is going to bring?